we roll there. Some rock, some wind, some 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 wind.
Whoops. Okay. Hi. My name is Loris Crow, and we are executing Showtime. Zig Showtime is the show where members of the Zig community come on stream to share coded ideas with the broader public. Every episode features 2 speakers who will present and take questions from you, the viewers. Zig Showtime, it's not just what you're seeing on the live stream, but also the discussions that you can have while watching, and that's why I encourage you to join one of the existing Zig communities that you can find by going to ziglang.org. And I'm serious about this. Please check out the existing communities. They're nice, they're interesting, there are a few of them, right now we are in a moment in the lifetime of Zig where we don't have gigantic libraries of programming manuals for Zig. We don't have, courses on Pluralsight, Coursera, Udacity, or other platforms. So this is a moment where to get the best experience with Zig, you kind of have to interact a little bit with other people. I promise you, it's not that bad. Not all the time. So, before we move into the first talk, let me bring up just a couple of news. 2 interesting news. One is that thanks to Dr. David Fuchs, for donating 3 Mac Minis to the Software Foundation. So we have 3 developers. Well, one is Andrew, and the other 2 should be Joachim and Jacob, who are going to receive, the new Silicon Mac Minis, so they can move forward with the development for that platform. And maybe I think right now, that platform is considered tier 2, and I think with this help we can also help move that to a tier 1 support. But whatever, I thank you, David, both from the Software Foundation, but also for me personally, because I bought a Mac Mini for myself too, and I want to play around with all the self-hosted stuff. So thank you very much for helping with this. Everything is coming together. So that's awesome. Okay, next point. The work on the website is moving forward, and if you go and check out sorry, I think I need another sip of water, of tea. So if you go on GitHub, there is a repository for the ziglang.org website, and if you check the issues, there's issue number 78 and issue number 79 that you might be interested in. In number 78, I'm requesting feedback for the website redesign that I'm working on. You will find a link to a hosted version or hosted preview of the website. It's still in an incomplete form, but I'm already at a point where I'm interested in hearing feedback, especially when it comes to the general structure of the website and the copy, the text. So you will find that there is a bunch of glitches, maybe with padding and smaller details, but which I'm gonna go through, of course, in the next few days. But the main discussion that I would like to entertain at the moment is about, if you will, the bigger picture. So where are we saying the right things on the main part of the front page? Should the menu be structured in a completely different way? And if you want to argue this point, you'll have to convince me. But it's easier to convince me, and maybe actually to really help me improve maybe just the copy for the existing structure. So if you see a sentence that you know how to make nicer, simplify, remove a word, or maybe I'm not a native speaker, so maybe I did something weird with the language. So I'm hoping to get this kind of help. Issue number 79 is also interesting, hopefully. That's a issue. That issue is a call for code snippets, because we are going to have a code sample gallery, and also there has to be a code sample on the front page. The code sample on the front page is going to be very hard to get right because we have a lot of constraints in terms of space, and that's the main code sample, so it needs to be meaningful, right? It needs to properly convey the right things about the language in a very limited space. So I'm hoping that people will be interested also in contributing, trying their hand at that code sample, and also at other ones that should go in another gallery somewhere else. Yeah, this is dog. That's the current example. It's a placeholder. But I mean, I've seen how many people were spending a lot of time doing the freaking code golf. So I'm hoping that especially the people that are at the top of the code golf gallery are willing to spend at least an equal amount of time trying to come up with a good example for the front page of the main website. Come on, it should deserve more effort than reducing the number of characters for a brainfuck interpreter or whatever. Okay, so and there's also a thread on Reddit on the same topic. The idea is that actionable feedback should go on GitHub, and like more serious discussion and other general ideas and general comments and questions should go more on Reddit, but it's all written down. Okay, and with this, I think I went through all the relevant news for this week. So I guess it's time to move into the first talk. So let me transition to the title. Okay. So Alex Naskos is back with another talk on interesting things that you can do with Zig. For the new people here, you probably know what an interface is, but you don't know in how many different ways they can work under the hood and how you can implement them in userland in some languages. The title is Runtime Polymorphism, Why and How. Alex, the stream is yours.
Hello, everyone. Thanks for the introduction, Loris, as always. So, about dynamic.
Alex, sorry.
Yes.
You got cut off terribly in the second half of your sentence. Oh, God.
Oh, sorry. Can you hear me now?
Yes.
Nice.
I hope it's just a one-time glitch. Yep. Please continue.
Cool. So today I want to talk about dynamic dispatch or runtime polymorphism. And let's start off. So what do we mean exactly by dynamic dispatch? There are a variety of methods that it can refer to, but basically the core is that we are selecting or dispatching a function implementation at runtime instead of doing it statically at compile time or at link time. So usually in most languages, you express dynamic dispatch through interfaces or dynamic traits. Sometimes they are called virtual methods. There are various names, but under the hood, they work pretty much the same. Of course, there are other paradigms like multi-methods, but I will not cover those. And I will talk mostly in terms of interfaces and virtual methods. So a good question to start off is, why would we want to do this? Obviously, this is an abstraction, and every abstraction has some cost. In this case, it's a performance impact. So we should be very careful about why we are using this tool and when we are using it. One of the reasons we do this, and we do this currently in the standard library, is to reduce the code bloat and the amount of generics that are needed to write programs when we are using some type that is inherently polymorphic. For example, the allocator interface is very naturally a polymorphic type. You can imagine 1,000 implementations of allocators with different characteristics, but they all share a common interface. However, if we relied on static polymorphism in this case, then pretty much 90% of code would have to be generic over an allocator type, at least up to some level. Obviously, once the user chooses a specific allocator, all the code could be specialized for the specific allocator. But for library authors, this would propagate everywhere. So this is one of the reasons you could do this. Of course, this is contentious. A lot of people would like to have some way to use allocators with static polymorphism, but it's a valid reason. And of course, the other most common reason is the flexibility of APIs that use dynamic dispatch, especially in an object-oriented way. For example, for plugin systems or graphical user interface frameworks, etc., where modeling things as objects is quite common, and you want to be able to extend the capabilities of libraries, etc. So, before we jump into actual code, here I am showing you the example of what we will be actually implementing in various ways. So this is using a hypothetical syntax and some kind of pseudo Zig code. We can see we are defining a widget interface. So that means that every function that is defined within this scope will be dynamically dispatched. Here we are just defining some draw function that will operate on the widget and will take some context and do anything. And we will want to define some amount of widgets. Just for an example's sake, we can see here we have a button and a text area. Each has its own state, which can be different, and it defines its own draw function, which can be different. I've just put some dummy code here. No reason in particular. I just didn't want to leave the functions completely empty. All right, without further ado, let's start with the most naive way one would do things in Zig. So this is using a tagged union. You can see we are defining the widget interface, and it has two fields, the button field and the text area field, which are just structs with the respective states and the draw functions. And the draw function of the interface itself just switches over the tag of the union and operates on the correct state. So this is very much what you would do as a first pass, or really the most naive implementation. And it's very simple and clear and very easy to use. You can see we are just initializing the object like we would with any type and calling the function, and everything is clean and works fine. So as we saw, this is very simple to define. Also, the ownership is obvious. Like, you only have this widget object which contains all the state always. So you don't have to keep track of some kind of state and some kind of interface object separately. Very nice. Of course, this can only work for a closed set of types. So, for example, if you had a GUI library that defined this widget interface, the user could not create their own widget and use it transparently in your library. You would have to use the widgets that are defined within this union. And the other disadvantage, which is not really relevant for most applications, but if the smallest field in the union is very small and the biggest field is very big, and you initialize a lot of small of unions that are set to that small field, then you are wasting a lot of memory. It's kind of obvious. You will have a lot of padding that is just unused, and this can lead to performance pessimizations, etc., because of cache misses, but in general terms, you will not. Usually the types are close together in size. All right, so let's go to the next notation. So this is using the pattern that's used in the standard library itself. As you can see, here we are defining our interface, as always. We named it widget. And in this case, it is what we call a vtable, or virtual table, which means that it contains a bunch of function pointers to virtual functions. So the functions we want to dynamically dispatch over. In this case, the function pointers take a pointer to the vtable itself as a first argument. So keep that in mind. I will explain why this is in a little bit. So let's see how we define an implementation type for this interface. Here we are defining a text area. I skipped the button definition for brevity's sake. And you can see, as always, we have our state here, the rect and text fields. But we have introduced a new field, which is the vtable itself. And for convenience sake, we added an init function that will initialize the vtable using the draw function that is defined in the text area. And interestingly, the draw function takes a pointer to the vtable as a first argument, instead of taking a usual self argument or a text area type here. And we are using the field parent pointer built in. So basically, given a pointer to a field of this struct, in this case, the widget field, the vtable itself. So given the pointer to the vtable, we can get back to a pointer to the whole struct itself. So here self will be a pointer to a text area. So in this way, we have effectively erased the type from the function definition. Here you can see that in this signature, there is no text area anywhere, but we know that this widget is a field of this struct. So we can easily use field parent pointer to get back to the state of the text area. And we do our usual stuff here. Of course, now initializing is just a tad more complicated. We create the text area itself, and then we have to take the pointer to the widget field, and this is our vocabulary type. This is what we pass around to call the actual virtual functions. So it's not too complicated, but it's just an extra step. So you have to remind yourself that this text area variable must stay in scope and be alive as long as this pointer is also in scope. So I think the one thing that's very nice with this pattern is that the interface object in quotes, or the thing that you pass around to call the functions, is a single pointer, which is very nice. It will be in a register 99% of the time, and everything is nice. It doesn't take up stack space or anything. Very good. Of course, one of the disadvantages is that the implementation type must somehow know about the vtable type or the interface type, because you have to use a field of the vtable type, which is not always ideal, and you could create some sort of wrapper to take some type that doesn't know about the vtable and somehow connect it all together. But it's one of the cons. And of course, instead of having regular self parameters, you are using a pointer to vtables, but that is just really not a big deal, as you just do field parent pointer and you're back to where you start, where you want to be. All right, so the next implementation, this looks a little bit scarier, but it's still simple, trust me. I will walk you through it. As far as I'm aware, this is probably what most languages do to implement interfaces or dynamic traits, etc. I know Go and Rust do this, but I think a lot of other languages do this too. So again, we have this concept of a vtable. Here we had just moved it inside the interface type. And now the interface type consists of a pointer to the vtable. And this usize, which at first glance looks weird, but this is just a way to store any pointer. It's just the value of a pointer. And accordingly, the signature of the draw function in the vtable has changed to take a usize in the first parameter instead of taking some specific pointer type. All right, here we just make a draw function that will call into the vtable. And you see that instead of passing a pointer to the vtable, now we are passing this object that we have stored, which is an address to the state of the implementation object. All right. And we have this additional function make that will take an object of any type and create this interface object. All right, so here we are doing just a little bit of metaprogramming by just creating a vtable instance at compile time. As you can see, we are setting the draw function pointer to this ugly thing, which will hopefully be solved soon with issue 1717. But for now, we have to make a struct to define a function in line. And we're just casting this value, this usize value, to the pointer type of the implementation object and calling the draw function with the always inline modifier. So basically, this draw function will be exactly the same as the draw function of the implementation type, but we are just doing it in a type-safe way instead of pointer casting the function pointer and having some extra assumptions. And we store the value of the pointer in the object field. So this is commonly referred to as a fat pointer or thick pointer because it's just 2 pointers. All right. Pretty self-explanatory. And as you can see, now we define the text area, and there is no trace of anything that has to do with the interface type. No widget, no vtable, nothing. Just have the state, we have our draw function. It's nice. And we can create a text area variable and store it in a fat pointer, which will automatically make a vtable for the text area type, take a pointer to it, and take a pointer to the text area variable. And everything works fine. So obviously the big advantage of this method is that the implementation type and the interface type are completely independent from each other. You could literally have a library A that defines some interface, and library B that defines some type, some other type, and if this type happens to match the interface, then you can just use it with no wrapping, no anything. Also, the interface object is still quite small. It's just a couple of pointers, which is not too bad. Usually in most calling conventions, 2 pointers are still passed in registers, so this is something you can keep in mind. But there is quite a bit of boilerplate. You can imagine that if you had, 5 virtual functions like allocator has, or used to have, then it can get ugly, but this can be reduced with some metaprogramming techniques that I will not go into because this is not the talk. but it can be done. All right, finally, here we have the final implementation I want to show you. So at first glance, this is quite similar to the previous implementation. We see that we are doing this always inline trick, etc. However, one thing has changed. Instead of having a fat pointer, so a pointer to the vtable and a pointer to the implementation object, we are still keeping a pointer to the vtable, but we also have this 48-byte array aligned to 8 bytes in the struct itself. So what we want to do basically is to store the actual object inside the interface object and keep a pointer to the vtable. Instead of having two pointers and having to manage the ownership of both objects, which is not particularly difficult, but for some, there are legitimate reasons you would want to have this type of structure where the interface object still owns the implementation object itself. This 48 number is arbitrary. I think it's the size of this text area struct, but you have to have some maximum amount of space reserved that you can fit an implementation object in. So the other thing that has changed is instead of using the usize as a first argument for the function pointers, we're using this funny raised type, which is a pointer to an opaque type. But it's also aligned to 8 bytes to match the object storage. I do this simply because the pointer casts, the compiler will automatically check that the implementation object you want to insert in the widget can actually be correctly aligned in the storage you have defined. You could also change this to 16 or something, or some maximum alignment. But I believe for most structs, line 8 is correct. All right, and the things that change here, I've changed the structure slightly. Instead of having make return the widget, it takes self as a pointer and returns a pointer to a requested type. So this way you don't have to copy the object to initialize it in the storage, but you can get a pointer to the storage directly and write your initialization values in there. And first, we just check that the type can fit in this buffer. And if it doesn't, then we catch it at compile time, which is nice. And we do the usual thing with the vtable. We create a vtable at compile time. We pointer cast from the erased pointer to the actual pointer type that we have been requested, and inline call the draw function of that type. And hopefully, it will generate the same code as it does for the original function, but this is all type safe and nice. And finally, we return a pointer to the storage casted to our type. I don't know why I have to align cast here. I think it's a compiler bug, but someone correct me if I'm wrong. Since the field is a line 8, this pointer should be a line 8 by default, but for some reason it's a line 1. And as usual, the text area stays the same. It's still completely separated from the interface type. And here you can see this is a bit more involved, but we just initialize the interface type and we set to undefined. And then with make, we get the pointer to the storage and we initialize it directly with the values of the text area. And we can call our virtual functions with ease. All right, so this is a bit of a mismatch of the tagged union style and the fat pointer, in that the ownership is the interface type owns the implementation object, like it did in the tagged union case, and we have completely separated the implementation and interface types, which is nice. And we still have the issue of wasting memory. You should just put a bunch of really small things in there, and you have a big storage, then obviously a lot of bytes are wasted. And we have boilerplate, which can be reduced. All right, so I have some small benchmarks. Of course, I should mention this. You shouldn't make any decisions based on the benchmarks that I'm about to show you. These are very small, simple examples, just to get a really general idea of how these things behave. So the methodology is the following. We make n objects where n will be shown in the legend of the graph. And we flip a coin every time. We use the standard libraries random generators to choose if every object is a button or a text area. And we keep all the interface objects, so the things that we actually call the functions on at the end to perform the dynamic dispatch, in a loop. We keep them in a slice, and the benchmark is just looping and calling the draw function. No allocations, nothing else, just a for loop and dot draw. That's it. And so I use the Zig bench, which is a nice library by Comar Spaghetti, and in the release fast mode, compiled in release fast mode. I should say I did some small modifications here to, anyway, very small modifications to the Zig benchmark library. All right, so let's see the pretty graphs, or the pretty graph. Oh, sorry. Sorry about that. I pressed end. So here are the results. Let me explain first. So the horizontal axis is the mean time it took to run a single iteration divided by the number of objects. So how much time it took for each call. The mean of that over all the iterations. You can see the red is for 100 times 1024 objects, and this ran for about 30,000 iterations. The blue bars are for 1024 squared objects. This ran for 3,000 iterations, like divided by 10. So we have 5 cases here. The first case is static dispatch. In this case, we don't have a single slice we loop over because obviously we have 2 different types. So I just made 2 array lists, initialized them with the coin flips like I talked about, and looped over the first one, looped over the second one. So this is the only difference. And the rest are the implementations we saw in the first index slide. Exactly the same implementations. All right. So the results are quite interesting, I think. You can see that the tagged union absolutely destroys the other implementations for small number of objects. So when we don't have cache misses, it's basically the same as static dispatch because the optimizer can inline everything in a single call. It's very easy for it. You have specific cases, so it makes a jump table and it just puts all the code in there, and it's very nice. While the other implementations are basically the same, and if you look at the generate assembly, which I did but did not include in the slides because it was not very interesting, to be honest, it's basically the same. It's pretty much, an instruction here, instruction there. What's an instruction between friends? You know what I mean? It's the same thing, right? But when we increase the number of objects, the union case quickly jumps up and comes pretty close to the rest of the implementations. Not sure why that is. Someone with more technical knowledge can tell me. But this is what happens in this specific micro benchmark. And we can see that the inline storage really performed quite badly. Still not sure why. I suppose it's the wasted memory, more cache misses, since the code is practically the same. Probably that. But those are my results. All right. Conclusions. Prefer union when possible. I said you shouldn't use this micro benchmark to draw any conclusions, but I'll still say that unions are nice, simple. The compiler can figure them out really easily. If you just have, I don't know, 5, 6 types that you want to be able to use interchangeably, just use a union. It's nice, simple, clean. Everyone understands it, even the compiler. Of course, if you want to use another solution, you should profile your application with different settings, tune it, see what's the best. Right, so there is a bit of a discussion around whether we should have a language feature for this kind of stuff. Personally, I don't think so. As I showed you, there are quite a few ways to implement it. I don't think we should be locked into something specific. I mean, users have preferences, and it's Zig after all. We have to be explicit, so I don't know, you explicitly write what you want your dynamic dispatch to do, how it has to work. And I do think that perhaps there should be a module in the standard library that is very tunable, and you can change parts, how the implementation object is stored, if it's owned or not owned by the interface object, stuff like that, to write dynamic dispatching concisely, but still with exactly the characteristics you want to have. Of course, there are a lot of things you can do. I just showed you some pretty simple things and usual implementations you can see in other languages, etc. You can look into multi-methods. It's quite interesting. I haven't really seen a compelling use of them that I really felt was nice, but I'm sure people use them for all kinds of nice things. Another thought I had, but I didn't have time to change my slides since I thought about it like an hour ago, was just taking the union and adding a dynamic field at the end, which would be the vtable pointer and the storage, so that the union is still the same size, but you can also store arbitrary objects that fit the interface. This could be quite interesting. I think it would perform like pretty much the same as the union case when you use one of the other fields, and as the inline storage plus vtable pointer when you actually use this dynamic field. Since, I don't know, it seems logical to me that it would be just an extra comparison and jump to the case where we do the indirect call. And I have a library interface.zig that does some of these things with metaprogramming. But yeah, I'm not here to shill my library. So that's the end of my talk. Thank you very much for watching, and questions?
Thank you very much, Alex. So let's give a moment for people to come up with questions. Also, let me enable my webcam so people can see me. Hello. Wow, that was interesting. I wasn't aware of all these possibilities. And yeah, by the way, the thing that you mentioned at the end, the having a tail, like a trailer of bytes after the in the interface, I think that's something that totally makes sense to have as a library. It's something that I searched for other reasons, not connected to interfaces. But like, yeah, I've already seen a couple of So I've seen that being used in the radix3 library by Antirez that I was playing with a while ago, and I also would have liked having an easy way of doing that for my own cuckoo filter library, which right now it's just like treating. It has two chunks of memory. One is the struct, and that has a pointer to the
Right,
to the filter
I see.
itself, which is an array. And having them being fused together would be very nice for many reasons. But yeah, I think it should be a library so that it can compute like alignment and do a bit of math, so that you don't have to. So the question, I guess, at this point is, when are you going to write it, please?
I mean, I think the standard library does something like this in the AST.
Oh,
But yes, it's pretty much pointer math handwritten. So I'm not sure if you can do it much more nicely, but I don't know. I'll think about it.
that's a good question. I don't know. Maybe like in my case, it would be super easy because in my case, I know what type I want to store in there. So maybe I can use that, or a general idea. I don't know. Yeah, I mean, you raise a good point. I don't know, but so let's see. There should be a couple of questions maybe already. I think there is one. By the way, just to give a bit more time to the people. I think that's your third talk, is it not?
It is indeed 2.5 technically.
Yeah, but I think we can count the first one as a full one. It's fine. I mean, I don't think August is gonna, unless August is gonna come and maybe want to reclaim his half of the talk. Now, regardless, I think that can count as a one full talk for both of you. So yeah, T-shirt. We need to talk about T-shirt after we're done with this.
We will.
So yeah, Alex is a little bit blurry. That's his webcam. That's how it is today.
Sorry, guys.
That's your phone, right? Are you connected with your
Yeah.
with a cable, or is this Wi-Fi?
No, it's over Wi-Fi.
Nice.
Probably not a good choice.
I mean,
retrospect.
It's fluid. The resolution is atrocious, but at least it's fluid. Very smooth. So, Greaser had this question where he was wondering how would you calculate. So you had that example where you had a space for 48 bytes, right?
Right.
And Greaser was asking, so how would you go around actually computing it instead of hard coding it? Like, how would the code look like?
This is not something you can compute unless you have some list of types already that you know. These are the only types that will be that will be stored in here. And if you have this, you should use the union. This is just some arbitrary size. You can just pick a nice size so that your whole struct is there is no padding left at the end, right? So that the size of the struct, when aligned, the storage goes to the end, if you see what I mean. Something like that. But yeah, there's no rule. It should just be an architectural decision of what kind of objects are going to be stored in here and things like that.
Mm-hmm. So let me see if we have any other question.
Oh, sorry.
Yeah.
I should also mention in my library, but anyway, in general, you could do something like also making the storage a union of either this array, like this row array, or if the object you want to store is bigger, then use an allocator and defer it, like actually heap allocate it and keep the pointers to the allocator and the object instead of the storage. it's not too hard to implement. And this way it can be super flexible, and you don't heap allocate when the objects are small enough, and you just heap allocate when you need.
So I have a couple of questions now that I think about it. So one is, you mentioned how, in your opinion, it's fine that allocator is a dynamic dispatch interface, but I don't remember precisely when. But reader and writer used to be also dynamic dispatch interfaces, but now they are comp time, right? So what do you think? What do you say about those?
That's a good question. Well, for one of the differences I would say is that usually in user-facing code, right? Let's just ignore libraries for a second. You will have specific readers and writers. You won't just make everything generic and have a call in main that actually sets the correct type. You have files, you have sockets, fixed, and you want to use a fixed buffer stream for some reason. You have stuff like that. So you always specialize early. With allocators, I'm not quite sure this is the case. An argument could be made. I don't know. I'm kind of ambivalent on this. I would actually like for the standard library to provide versions of containers that can be specialized with generic arguments for allocate. But I would also keep the interface of the student mem allocator for people that want just put it there. And I will say that I did some tests for devirtualization. So the compiler figuring out that if you're only using one implementation type, it can just remove all the indirect calls and just stick the static dispatch in there. And it's quite good if you are using one type, which is quite common with allocator, because one bunch of code will use one allocator type, another will use one allocator type, etc. You don't have an array list of allocators that you iterate over and allocate with, right? It makes no sense. So LLVM is actually quite good at the virtualizing those calls.
Okay.
Even with the field parent pointer pattern, which I did not expect, but it does well.
So, okay, that was one. Let me think. I think I had another question. I might have forgotten it when you were replying. So, yeah, we talked about I/O being like this. I think I forgot it. So I don't think we have other questions from the public. But I think this is a good thing. I think your talk was very clear in the techniques and the things that you can do. Yeah, one thing that I would like that would be very interesting to explore, if there was a way of somehow switching between one and the other, like being able to provide both and make that work nicely. But I haven't thought about it much.
Do you mean between static and dynamic dispatch?
Yes, right. Like in a way that you could say, choose which version you want, and there is not too much code duplication to support both.
Yeah. I've had some thoughts about it, but I don't have a specific solution in mind yet.
Understood. Oh yeah, and now I remember my other question. So one thing that you mentioned about the field parent pointer technique is that the interface has to live inside the concrete implementation, right? You need an instance. You had an instance of widget inside the text area.
Yes.
And you also mentioned that I guess what is in a sense maybe really the biggest downside, which is that the concrete type has to be 100% aware of the interface type. But another, I guess, more mundane problem, but that people do encounter is that I stumble upon it at least a couple of times, is that you cannot copy the interface struct away from the parent struct. If you by
Yes,
mistake
yes.
copy that struct away, you
Good point.
jump, like the field parent pointer line, the one that computes the offset from a field to the base of the struct, starts pointing
Yeah, it's
to
just
garbage,
yeah.
and it's
Yeah, this is very frustrating.
yeah, it's good fun debugging this kind of stuff.
I
So
think actually, sorry, go ahead.
please go ahead.
So, well, yes, this is true. I didn't actually consider it, but that's a very good point. But I think there is one way this could be mitigated by, instead of having a field, which is the vtable itself,
Mm-hmm.
so a studmem allocator field, for example, you could still have a pointer field and use a pointer to a pointer instead for the field parent pointer, and set the pointer field with metaprogramming like I do in the other cases, like generate the vtable, etc.
Mm-hmm.
And it should probably still work and have similar performance characteristics. Not too sure, but yeah.
Well, I think there were also a couple of there was an issue, I think, at least one issue related to this problem. It was about marking. There were a few takes on what the solution could look like, and those were about, like, I remember the keyboards. Like, one was adding a pin mem keyword that would say this is something that cannot be copied, and you can only take pointers from
Right.
it. Or there were a few other options which I don't remember. Do you have any opinion on any of those?
Haven't really thought about it, to be honest. I guess you could say that this is somehow tied at this offset of this track, but it feels kind of weird to me.
Mm-hmm, mm-hmm.
I don't
Yeah.
know.
Yeah, well, in any case, if you're watching and you're doing something with interfaces, and at what point you see your program misbehave in ways that don't make any sense, chances are that you extracted an interface outside of its concrete implementation, and now every time you call that function, you are doing a lot of things that you should not be doing because the offset computation.
I guess this could be also solved with runtime safety, like by adding some fields with special values at some specific offsets,
Right.
doing checks or something like that.
That's a good point, because at the end of the day, these are like programming mistakes that by, like, you try to compress, like you try to you just want the interface, right? Because that's what you need to pass to other functions, or you want to use at the end. So you just maybe chain too many things together, and you don't care about the intermediate value of the concrete implementation. So a runtime check that catches the error immediately, the first test that you write, that would be already yeah, I think that already would be an 80% solution to the problem. Yep. Okay. So I think we don't have any other question. If you, I don't know, do you have anything else to say before we move forward?
Keep on rocking. Help with stage 2. Thanks for the Macaninis, David, if I recall correctly.
Yes.
And see you guys.
Thank you, Alex. Okay, so we are now moving into the break, 10-minute break. You are allowed to tab into another Twitch stream if you want to, but come back after, because we're gonna talk about expressions in Zig. If you're new, it's gonna be surprising, I assure you. If you're not new, you might want to stick around still, because there will be a couple of, this is actually really a 50-50 presentation where it's also for more experienced people, and the bad things that I know you are doing with expressions. So I guess see you soon. Okay. 1 minute and a half. Are you ready? I'm not. I need to still to set up my screens. Let's see. So this this. So I'm just running through my slides very quickly just to make sure I didn't make a mess of things. I think we should be good. By the way, for the joy of Hayes and other people complaining about my my fancy font, I have a couple of complex, relatively complex slides with like a few lines of code. And if it's more than 3 or 4 lines of code, I switch to a normal font so that you don't have to decipher the usual blocky old school style font. Okay, so the slides seem reasonable, I think. Is this doing the proper animation? Yes, it is. Okay. Okay, we should be good. So let me reset the presentation. Okay, time to tab out, tab away from Shroud, Moon. Well, if you're watching XQC, shame on you. By the way, I'm just throwing names around. I have no idea who is live now. Okay. Hello. Black screen, of course. I forgot to set this. There we go. Here's the slide. Okay. I hope everybody's ready. So, the title is in Italian, as you might have noticed. It reads Virtuosismi d'espressione in Zig. And the reason why I'm using an Italian title is not just because I got lazy and I didn't want to think of an English title, but it's because we're talking about virtuosity, which I think it's a loan word that English has from Italian, I guess from Latin. Well, I guess maybe it doesn't even classify as a loan word, but the point is the idea of virtuosi and this type of it's a music thing. These are musicians. I guess is fairly tied to Italian culture and the good old times in the 1800s where music was mostly Italian. That's why you still have allegretto and all these music words that still float around. And this is from the 1800s and more or less sooner or later, I don't know, good times, plague and all. Not so different from today, actually, right? But jokes aside, it's from this era. So let's talk about this kind of stuff and how this ties into expressions and Zig and good and bad things that one can do while programming. So the translation of the title, Virtuosismi d'espressione in Zig, I guess would be expression virtuosity in Zig. That would be English version of that title. And as I was saying, this comes from music. And here you have this painting. They didn't have selfie cameras at the time, I guess, of this guy playing violin. And I think this is Paganini. I'm not sure. This is actually, it kind of looks like him, but it's a painting, so you never know. Well, you never know with pictures either. I mean, people definitely go overboard with filters, but I just googled virtuoso on Google Images, and that's the first picture that comes out. Now, what's funny about this painting is that this is not a super flattering painting, right? Look at the guy. He broke the strings of his violin. Why? Because virtuosi are the people that used to be very good at playing super fast music. Like they would be able to execute very complex pieces. And they would take pride in that, and like they would probably go around and showcase their abilities. And this is again, this is where the whole idea started, I guess. But it's not unique to them, right? You have also in more modern times some players do a solo piece where they show off their skill. Now that we know what a virtuoso is and what virtuosity is in general, let's talk about Zig. Let's talk about statements versus expressions, and let's just briefly mention which is which. So this is a quote from something I found on the internet. I don't even remember where, but it says, in computer programming, a statement is the smallest standalone element of an imperative programming language that expresses some action to be carried out. Expressions are instead smaller pieces that produce values, and sometimes you find expressions embedded inside statements, at least in imperative programming languages. I'm sure functional programming and other stuff has weird rules about all of this. But if you're just talking about Zig, and we just try to analyze a simple line, you can see that 3 plus b is an expression, and actually 3 is a value, and b is a value, which also are like the simple expressions, right? But then they combine with the plus together to become a more complex expression. And then you have the function call, which itself is an expression. And then everything else is a statement. Now, I'm not being super precise with this stuff, because I think A is a value too, maybe, I don't know. But again, this is not to pinpoint exactly what everything is. If you want to know that, you can just go read the Zig grammar and you'll figure out what is what precisely. The point is to get a general feeling for the normal people that are doing their day-to-day programming. Now, let's bring out a slightly more complex example. So now we have a if statement with also an else branch, and now I just spoiled it. It's an if statement, so it's a statement. Now, if takes an expression between parentheses, that it's a Boolean expression, right? It has to evaluate to a Boolean. Then you have a block, and inside the block you can have a sequence of statements, and this statement happens to be a function call. In the else branch, you kind of have the same thing. You have a function call which evaluates to a value that gets assigned to b, and b is itself a value. And all of these makes up a statement. So statements have expressions in them and also have other statements, and like the rules are a bit customized, right? If looks like this, for, while, each own has its own set of rules that decides what the allowed layout is. Now, how do you know what a statement is in Zig? And the answer is either it ends with a semicolon, so a chunk of something that ends with a semicolon, like more or less a line, I guess, or it's a control flow struct, so it's an if, it's a for, it's a while, it's a switch. So I guess this is a rule of thumb, right? If you see something that ends with a semicolon, that's a statement. If you see an if, that's an if statement. Then there's a for, that's another statement, while, switch, etc. So here's the problem though. Look at this. This is valid Zig code. And what you're seeing here is that we want to assign a value to A, but what we end up assigning to A, which can be either 1 or 0, depends on what x is, and we know that x is a Boolean value. So what is this up here? This looks like an if statement, but it's not really. It's an if expression. So in Zig, you can use control flow constructs also as expressions. This is not super unique to Zig, so I'm not expecting people to go, oh no, really. The slightly more surprising stuff will come further towards the end of the presentation. So, but this allows you to do nice things. Like, so you just saw this with the if else. This is not surprising. And I mean, is this really that different from the ternary operator that C and Java style languages have? No, not that different. Also, you've seen this already in Python, although with a funky order of tokens. But let's go to a more complex example. So this is a normal switch. So we have, again, as usual, I bring out the heavy artillery of dumb examples. And this is a is prime function that takes a very limited amount of numbers. And because of that, it can cheat and just hard code which are the prime numbers. So what we are doing here, we have a switch, and we are switching over the value of n that goes from 0 to 8, from 0 to 7. And if the values are 2, 5, 7, we return true, otherwise we return false. Nice, this works. But this can also be rewritten like this. We return, and return has to take an expression after, and the switch becomes the expression. So now we have switch, and the switch then evaluates to either true or to false. And look that now we have a semicolon in the end. Let me switch back to the previous version. The previous version doesn't have a semicolon. This one does. So you can see that you can do both, and there are some slight differences. Like if you forget the semicolon in this version, you'll get a compile error. So this brings me to the... Oh, there's also 3. Did I forget 3? Yeah, of course I forgot 3 from the slide. Sorry, I was trying to be smart with the 2. 1 is not a prime number. Sorry, Nectro. That one was right. But yeah, I forgot 3. Whoops. Anyway, don't steal this code, please. So this brings me to the hardest Zig question. When should I put the semicolon? Because if you start nesting this stuff around, you'll end up to a point where you get confused. Do I need a semicolon? Do I not need a semicolon? The answer is, while in practice it's not hard to get confused at first once you start nesting a few things together, but the general rule is very simple. You should use a semicolon in the end whenever you're using ifs and switch and for loops and while loops as expressions. When you're using them as expressions, that's when they need a semicolon at the end. Or more precisely, they need a semicolon in the end because they are embedded in a statement. More probably, they are embedded in an assignment or in a return. And assignments and returns have a semicolon at the end. So actually, here, this semicolon, in a sense, is the returns semicolon, right? Like this switch, if you substitute this switch to its final result, like let's say that they ends up being true. So you have return true and then semicolon, like you always do in all return statements. So that's when you need a semicolon. Now, if you nest stuff together, so for example, if this branch had inside of it another if expression, that if expression would not need a semicolon at the end, because it would be another expression nested inside an expression. Like nested function calls don't need semicolons within them when you're nesting stuff. Let me give you a bunch of pro tips about this. So pro tip number 1, you can do this stuff also with loops. It's pretty nice. So you have a while loop. By the way, here's the font that's easier to understand, easier to read, so that I can put in slides more complex examples. So this is an in-range function. Takes a beginning, takes an end, takes a number that we are searching, and what it does, it returns, and then we have a while expression, and this while expression is pretty wild. So inside the while block, we have a break that also returns a value. So this breakthrough breaks out of the while loop, but it brings the value with it. So we return true from the function when this when this condition is true, when we found the number that we wanted. Now, if we don't find the number, there's the else branch. This else is an else branch for the while loop. So while loops in Zig have else branches, and what basically this does is this executes if the while did not break. It's basically used for searches. The idea is you have a while loop that is searching, and if the search succeeds, you break the moment you encounter the right condition. Otherwise, if you don't break out of it, then the else branch is the not found case, basically. And again, this is not unique to Zig. I think Python also has else branches to their while loops, probably a few other languages, but I think it's pretty neat. And you don't have this stuff in C, I suspect. So that's nice. Problem number 2. Oh, yeah. Let me see. Let me actually react to comments in real time because I think it's available. So the Geek Pirate says, why doesn't the else have brackets around? That's more complicated, the Geek Pirate. So the problem is that if you put just the value here, this is the return value. If you put the false inside brackets, this is not like Rust where you can just put a final thing at the end and it works, which personally I don't like. If you put brackets, then it becomes a block, and block don't evaluate to the last thing that they have inside. Blocks evaluate to blocks without labels just evaluate to void. And so you will not return what you would like to return. If you had to put a block here, you would have to do something different, which I'm going to show in a later slide. So keep that in mind. We'll go back to that later. So tip number 2, you can even do this stuff with returns and panics and other things that that play around with control flow, and it works. So we have this example where we have foo. We are trying to assign to foo. We don't know foo what is. We don't even know what bar is. But bar has a case where if it happens to evaluate to that bad value, we want to panic. And this compiles. This works because here we are not returning a proper value to assign to foo, but we are panicking. And once you panic, it doesn't matter whatever you wanted to assign to foo because you're jumping away from what's happening. So the same happens with try. Like if you had a branch that had a try in it, it would still compile because assuming that the success case of the try would still match the type of foo. Because if it fails, again, we have the same semantic, and that's powered by the no return type, I believe. In any case, the implementation doesn't matter. The good thing is that you are not constrained in this case that if you have something that tries to return or tries to break control flow, then you cannot use this trick. You can totally do it, and it still makes perfect sense. Pro tip number 3. Use labels to return values from blocks. And this brings up to what the Geek Pirate was saying. So if you end up in a situation where you need to do more things, so for example, this is the isPrime function, and if it ends up being the case that n equals 1, we have to do things, you can do that. You just need to use labeled blocks. So labeled blocks, you can read about them in the language reference. I'm not gonna spend too much time, but the idea is you give a name to the block, and when you don't have a good name to give to it, you just use BLK. And labels also allow you to break from, like if you have a bunch of nested blocks, you can break up to the level that you want. That's why it's nice to give them names. Because in some languages where you don't have this, you can only break from the inner loop when it's loops or the inner block anyway, and it's annoying not being able to do better than that. And here, basically, what we're doing is inside the block, we are performing the side effects that we need to do, and then we evaluate the block to the value that we want to return at the end. And that basically covers everything. So whenever you can, just use a naked value or a naked expression that then evaluates to what you want to return. When you can't, label blocks. They can bail you out. So I hope Git Pirate this answers your question. So protein number 4. You can even put expressions in function declarations. So this, if you're one of the metaprogramming junkies that have played with comp time and done all kinds of different things, you probably know about this. But if you're kind of new, I mean, you've never done anything like this kind of feels weird. And again, I have another terrible example, but I'll mention one real case for this. And that's so look at this. I have foo, which is a function that takes in any type, and here there should be my return type, right? But there is a function call. What's up? So the idea is that you can put a function call where your return type should be, and if that function returns a type, Zig will evaluate that function, to decide what the return type of your function should be. Here I'm doing something very stupid again, as usual. I'm not even trying to find a compelling example because with slides you don't have enough space to do anything meaningful. But the idea is this bar function takes in the type of this argument and does a bit of comp time metaprogramming on it and says, well, if it's a Boolean, you know what? I'm going to compile error. I'm going to fail the compilation and say no. Otherwise, it's fine. I'm going to return the same type back. So basically, this function becomes an identity function, right? You give it x, it returns x. Well, you give it x, and whatever type of x you give, it returns that type back, and more precisely, it returns x itself. Except for Booleans. If it's a Boolean, no, this doesn't like Booleans. Now, this is not the right way of implementing this check. Like, if you don't want to accept a specific type, the nice thing to do is to put the check as the first line inside the function's body, not to play around with the return type. But one more legitimate example of specializing, changing the return type based on the type of a generic argument, input argument, is, for example, what the square root function does in the math, in the standard library std.math. So what happens in there is that a square root can take as input also, for example, signed integer, right? Like the number should be positive, but the number type can be signed. And so what that function does says, well, if you're giving me an signed number, so I don't know, a E64, I'm going to return the unsigned version of this because square root only produces positive numbers. That's a small optimization. The second optimization that square root does is that square root always reduces, right, your number. Gives you for what's it called? If we're talking about like integers and stuff. And what it does is that it halves the bit size of your number. And it does it basically through the system. Like it inspects the input type and then makes decisions on the return type based on that. And you can read it in the standard library. It's very nice to read. Now here I'm using a function, but that's my choice. What you could do, again, this is an expression, right? What you could do is that you could even put the entire switch expression in there directly, or an if expression. So you don't even have to resort to functions. You can put something that just evaluates to a value of type. So again, terrible example, but generally useful and kind of surprising, right? Because you don't do that in Java. You don't even do that in Python, I think. I mean, well, in Python, you don't specify types, I guess, and you can make a mess of things anyway. But in static typed languages, you don't do that way usually. Anyway, this is nice. But let's go back to Virtuosity for a moment. And this is, now I'm moving to the part of the talk for people that have a bit more experience. So I'm not going to present anything surprising about the language anymore. And I'm going to talk about what people do with things, should do, shouldn't do with things. Again, and this is just my opinion. But before we get there, let's talk about music. So Virtuosity music, it's an interesting concept because virtuoso players are people that want to play hard pieces. Their whole shtick is being good at playing fast, hard stuff. And sure, speedy pieces are a lot of fun, so it's understandable. Makes total sense. But what is really the ultimate goal? Is it just speed? And again, one can do whatever they want. So I'm not really saying, oh, if you try to go for speed, then no, this is morally wrong. Absolutely not. But, and this is in my opinion, if your goal is being a good musician, in my opinion, means that you can make beautiful music. So if you're a player, you play an instrument, it means that you are using the instrument for the ultimate goal of performing beautiful music. And technical prowess is a tool that allows you to get access to a wider range of music. Like if you, I played clarinet for a few years in high school, and if the fate of humanity depended on me being able to produce good music, unfortunately, we would not be in good hands, because quite literally almost, because my skills with the clarinet are limited, and that means that there are a bunch of very nice things that can exist, music pieces that can sound nice, that I simply cannot play. But when you take the virtuosism thing to an extreme, the problem is that being able to go extremely fast doesn't make you a better musician automatically. And actually, it can even detract from it, because it's not trivial to go super fast. And it's not trivial to be a good musician. And if you invest too much time if you over-optimize, if you over-specialize into going super fast, the more you do that, the higher is the chance that you're missing out in being a better musician. That said, again, the one thing that I would like to point out is if somebody just really loves playing fast stuff and is really interested in super hard stuff, I'm not judging the intent. You can do whatever you want, do whatever you enjoy. But my point is, you should not think that you're a good musician because you can do you can play music fast. Now, let me bring an example of this. This is subjective, but I would really like for people to try this out and tell me if you see what I'm seeing. So, case in point, an example of this. So here we have Niccolò Paganini, which I think he was also the subject of the previous painting. I think, maybe. Anyway, so Paganini, I think he was pretty famous. Violin, virtuoso composer, super good musician. And he made a piece called La Campanella, the handbell. And it's a nice sounding piece, but what's even better, it's the version that Liszt made of La Campanella. So Paganini made it for violin, and Liszt adapted it to the piano, to the pianoforte. Now, that piece, I like it a lot. And again, I'm not a super expert in classical music. Like, don't think of me as some kind of like classical music junkie or anything else. I just stumbled upon this stuff and I ended up liking it and learned who made it. But more importantly, so we have La Campanella for pianoforte, which is a piece created by a virtuoso, adapted by another virtuoso, and it's pretty technically challenging. Then we have this guy, George Bolet, and I know, I'm kind of mispronouncing his name, but I think that's how he pronounced it, because he's from Latin America, but he moved to the United States, and he always used a more Americanized pronunciation of his name. So George Bolet is a piano player from a more recent era, and you can find on YouTube him playing La Campanella. And I invite you to compare the recording of him playing La Campanella versus other players. And what's interesting is that he plays La Campanella slightly slower than other virtuoso players. And in my opinion, his version is dramatically better than the other ones. Actually, I think that the other people that played this piece faster completely missed the point of this piece. Again, this is not a statement that I'm making generally that you should not go fast. Absolutely not. My point is, the ultimate goal is doing good music. And George Bolet, in my opinion, got this right. Other people missed the point completely and did miss the point of this piece by playing it fast. Again, this is still pretty fast. It's still pretty hard. He's not going slow. He's going just slightly slower than others. And I'm very unimpressed by others people play compared to his. So in my opinion, playing that piece slower is what makes Bolet the better musician. And here's my invite. Google La Campanella Bolet and see and listen to it. And also Google, search on YouTube, other people playing La Campanella. You'll find a few others. They're all very skilled, very good musicians. Not as good as Bolet, though, in my opinion. Again, that's just my opinion. But this is one example where in music, where this whole virtuoso idea comes into being, where there is how can I say? There is a tension there, because on one hand you want to play maybe for the public, on one other hand you maybe want to do something that feels good for yourself as the player, and you want to do something that feels good to play, but maybe it doesn't sound as good, and that's reasonable. But at the same time, if your goal is to be a musician and you focus too much on speed, you end up doing something embarrassing. I honestly think it's embarrassing. So take a look, take a listen to Bolet versus other players for La Campanella. Find pianists, find the version of La Campanella adapted to piano. So don't listen to the violin version. It's too different. Okay, that's it. Back to programming. So how does this relate to us? So why did I go on a tangent with music? Well, we also are in a bit of a not too different situation compared to musicians, in my opinion. And we also are in the situation of, well, how much should I nest expressions? How much should I try to be a expression virtuoso? And the answer is, we have an answer in the Zig Zen, which I recommend you take at heart. And in my opinion, being a good programmer means that you write stuff that is understandable for the computer and also for other humans. So in the Zig Zen, we have favor reading code over writing code. So try to use nesting expressions not just as a way of being extremely concise, the lowest number of lines possible. Use expressions to write clearer code. And I'll give you also my take on what clearer code means. So I'm gonna try to give you, in my opinion, what covers 80% of what you will end up doing. So this is an example that Felix recommended, which I think it's very, very nice. So here we have maybe foo, which is an optional type, and or else is the operator that unpacks a optional. And basically, if the optional ends up being the actual thing, that's what gets returned. Otherwise, or else will execute the other branch, I guess. So in this case, we are also using the early return thing, right? So we're doing or else return an error. And that's not bad. That's a nice one-liner, which in this case is not just one line because we don't have enough space in the slide. But I think it's a reasonable, very readable one-liner. You can also see this type of concept. Again, this is also coming from Felix, where you have the current working directory, you open a file, and then you try to catch errors. You switch over the error. And in this example, we don't want to fail out completely if the file is not found. If the file is not found, we want to set this value to null. So this is an optional file because the application that we're writing is fine if the file doesn't exist. Maybe we are trying to find a configuration file, and if the configuration file is not there, we're going to use the false, just as an example. So in this case, we return null. Well, we set null to file. Otherwise, if it's another type of error, something different, we want to return that error, and that's fine too. And this returns from the whole function that I didn't include in the slide. It doesn't assign e to file. That doesn't make sense. This is an error that gets returned from the enclosing function. And I think these are all nice passages, like common combination of things that work very well together and help keep the code kind of readable. Now, let me show you a bit more advanced one that this one was recommended by Alex. And it's a bit more virtuoso, I would say, but still not bad. So here we have a list, and this list is probably a list that has taken an allocator in when we initialized it, and it's using the allocator internally to allocate new nodes whenever we request, whenever we ask it to. So add one adds a new node to the list, a new element, but this can fail because the allocation can fail. So here we are enclosing everything in parentheses so that we can say, well, if this fails, try will return an error. If this succeeds, then this will give us a pointer to the new node, and we are going to set the content of that pointer using the .star operator to whatever we need to set it to. That's not bad. You can see that having to use these parentheses is already a bit of a stretch, a bit annoying, but like in isolation, I think this is somewhat harmless, still readable, not bad. But this brings me, I think, to the deeper truth about what we try to achieve when we nest stuff, when we nest expressions. So why do we nest expression? In my opinion, again, this is not a 100% thing. This is, I'm trying to cover the 80% case. I'm sure there are 80 to 90% cases. I'm sure there are corner cases where you're doing something different. It's more specific, but so I don't want to lose the nuance, but I want to cover what people end up encountering or doing in their day-to-day. So why nest expressions? And I think that one point is that it allows you to avoid intermediate assignments, right? If you did not nest those expressions and those expressions were necessary, then you would otherwise put them into separate statements and assign them to intermediate values. So what's wrong with intermediate values then? Well, it's nice not having intermediate values because you can keep the lexical scope clean. Once you add a new variable, you can't retract it. Like, it's in there and you have to reason about it. And keeping the scope, the lexical scope clean, it's a nice property to have. The problem though, the downside, the not nice, is that if you overdo it, you make a passage, and I say passage just to say it's maybe one line, maybe it's more than one line because it's a clump of stuff, but you make it harder to understand a part of your functions body. And so here you were gaining in clarity, but here you're losing in clarity. And at one point, one thing is not worth, like at one point the equation flips around and it's not worth anymore doing whatever you were doing. So the important part here, I think that really this yellow part, it's really, really valuable. I think this is really, really nice. Wanting to keep the lexical scope clean helps a lot with clarity. And this brings me to the pro tip number 0. Yeah, clean lexical scopes are great. So let me give a couple of examples of this. So this is an example taken from the docgen file, which I was playing around with a couple of days ago if you were watching the streams. So it's a very normal function. At one point, it's there is some stuff above that I omitted. But at one point, it tries to open a input file, it tries to open an output file, and then it just reads the content of the input file. It reads everything immediately, and then it instantiates a buffered version of the output stream. Now, this is fine. This is not bad. This is perfectly reasonable. But I'll tell you that after this, so underneath in the part that I omitted, we are never going to use ever again out file, in file, we are only going to use input file bytes and buffer out stream. So these values here were important, were necessary to produce what we needed here and what is going to be used afterwards. But now these things are still here. You can't completely forget about them. And especially you as the reader, while you're reading down the function, you don't know if these are something that you can forget about, or if it's something you have to keep in mind because this character here will come out later in the 6th season, way down below, 1,000 lines below. So how can we improve this? How can we make this clear, easier to understand for people who are reading? Or before that, actually, let me show you how to make it worse. Let's make it very much worse. Here's how you make it worse. Here's a very bad idea. Well, if I don't need everything that I use to get to the input file bytes, why not just chuck everything into a bunch of nested expressions? By the way, this would be another very long one-liner, right? Which I'm breaking down into separate parts because of the slide. Why not do this magic thing? Now, let's forget even for a moment that this prevents you from being able to defer close the file. But I would argue that even if that wasn't the case, this is not nice. This is really not nice. And by the way, while this is, this is not great. And by the way, while I was rewriting that code that I showed you earlier, because I'm making another implementation of it, I'm adapting it to something different. I went through this part actually while I was rewriting it, but thankfully it didn't stop there because this is not nice. And I'm not the only one. So here's me publicly shaming Soapstone. While I was preparing this presentation about 3 to 4 hours ago, I was in Discord and there was Soapstone in his channel who was showing off his exact line where he's doing this kind of crap. And so, yeah, it's real. And like, my point is, it's not nice, but we all do this stuff. So let's be real here. Try to avoid it. So how do we make this nice instead? How can we better than Soapstone? I don't know if you can, but how do we make it clearer? So here's a good idea. A good idea is, well, it's a starting point. You can use these curly braces here to add a lexical scope. But adding, maybe you don't do that much. Like you can do this in other languages, but it's not something that I've seen used too much. I've personally done this in Go. I think I've seen a few examples in Go. I'm sure people do this in maybe C and C++, but the idea is you add a lexical scope just for the purpose of isolating names that you don't want to survive after they're used. So here, what I'm doing is I'm saying, well, the only thing that needs to survive is input file bytes. So I'm going to declare it outside, and then inside the scope, I'm going to do the initialization, and then this is what survives. I've seen also the annoying version of this, where like in stuff like Java, you are forced to pull out a name because you are inside a try-catch block, and it's annoying. Like it can be nice, but it can be annoying when you are forced to in some languages. So this is a good idea, but it's not the best idea. That said, I personally like this general pattern because you can do stuff like this. Like you have, maybe you're preparing a response for an HTTP response, and you have two clear separate chunks of work that have to happen one after another, but they are basically not related at all. So maybe you have the first part where you're setting the headers, and then down here you have another scope where you set the body. And I like doing this where I open curly braces, clamp a few things together, and put at the top a comment that says what I'm trying to achieve with this block. And sometimes we do this also with new lines, right? You put stuff together one next to another, and then you add one new line to kind of implicitly say a little bit, well, now this new part of what I'm trying to achieve starts. But this is more powerful because this allows you to prevent this symbol from from existing afterwards. So readers know that they don't have to keep this in mind. Now, the problem with the previous example is that something did have to survive and was input file bytes. And because of doing it like this, we needed to make it variable because we had to set it to undefined in the beginning, and then we had to actually assign to it. While in the previous version, this used to be const because we would produce it immediately out of an expression. So this is annoying, but we can do better. So while I like this, I love this. So this is the adapter version. It's not exactly one-to-one matching to what was before because in my version I added other stuff. I'll get to this in a moment. But the idea is you set the return thing as the result of a labeled block, and you break away from the block with the result. So you achieve basically the best of both worlds. You have only input file bytes surviving, and you have everything else hidden inside a block so that in file stops existing at the end of this. I think this is pretty nice. And also here you can see that I'm using an if as an expression again. In this case, what I'm doing basically is I have this slightly more complex version where by default, the file that I want is the standard input, but if somebody specifies the in file option, then I try to open that file. And this args thing, it's clap from Comari Spaghetti. If you search Zig clap, it's the command line. It's a command line library that allows you to, parse command lines. It's nice. Parse command line arguments. So anyway, details aside, here's the other half. So if you remember, there were two things that survived in the original code, right? Input file bytes and the buffered out stream. Now I cheated earlier because I didn't show you the vanilla block version of this other half because it's annoying. Like to set buffered outstream to undefined, I need to specify its type, and finding out the freaking type of a buffered outstream, which has we just mentioned it earlier, right? These are a bunch of generic interfaces. It's annoying to find out the type. So with the block, I can even skip that problem. Yep, I can skip that problem because the type gets automatically inferred by the compiler, which is nice. Okay, so these are the basically the things that I wanted to say. So long story short, in my opinion, expressions and stuff, really its main goal is to help the code be cleaner by not polluting the lexical scope with intermediate values. But at the same time, you have another opposing force, which is intermediate values help a lot when you are chaining a bunch of stuff together. The good way of mixing them is to not forget about scopes, and labeled scopes, labeled blocks help you also achieving that in a even nicer way than you would otherwise be able to. And I think that's a boringly simple truth, but when you put it in practice, not forgetting about labeled blocks does make a lot of difference. I personally have to admit that I'm not the best at using labeled blocks because when I started programming Zig, labeled blocks were kind of buggy, especially when interacting with inlined loops. And so at one point I stopped trying, but they are really, really nice. So let me bring out the conclusion slide. Read the language reference, learn where you can use expressions. You can do a lot of very interesting stuff. So you remember that I showed you earlier a bunch of switch cases, right? And you had a switch case where you had 2, 5, and 7, and I forgot the 3. Well, these are actually multiple cases collapsed into one, but the case itself, it's a value that can be the result of a comp time block or something like this. So you can even make interesting stuff with switch cases, which I think it's surprising. That's something that I don't think other languages have at all. So that's or at least languages that do this like that are not completely dynamic. So yeah, there are a lot of places where you can do interesting things with expressions. Make sure to read the language reference. Second point, once you do read about expressions and you know all the funky things that you can do, please go ahead, do all of them. Don't hold back. Do it until you can get them out of your system. You need to get to a point where you are willing to experiment with weird expression constructs, so that you can finally achieve the real goal, the pure goal of what expression virtuosity allows you to do, which is make the code cleaner, nothing else. And in my opinion, the unsung hero of this effort really are blocks and scopes. Use them. They really help reducing clutter. They are very simple, and they really solve 80% of the problem, maybe even 90%. Yeah, they really give you the highest bang for your buck. And I think that's it for me. That's actually the end of the presentation, and I just noticed that I don't have the end slide this time, so sorry. We stop on the conclusion. I'm happy to receive questions. I'll give people a couple of minutes to come up with questions if anybody has one, and in the meantime, I'll read all the comments that I missed from earlier. So let's see. Oh yeah, Luis Manfroni says, it's like dancing fast but without precision, out of the beat, or not making good lines doesn't make a good dancer. Yeah. Can I do like Paganini and send my soul to the devil for Zig skills? Maybe once we set up a program like that, we need to enable some kind of we need to find a startup that is able to collect souls for us, like some kind of Stripe but for souls. I'm sure Silicon Valley will come up with that sooner or later, and at that point, yeah, you will to be able to say also like Paganini. Good times, those were good times. So let's see. Let's see. I would do, instead of deferred file.close, to just file.close after const bytes. Okay, let me bring up that slide so maybe we can see. I'm assuming you're talking about this slide. By the way, Nectro, correct me if I'm looking at the wrong slide, but let me tell you why you want to put this here in a defer and not under input file bytes. The problem is that input file bytes can fail. And unless you do something different, like if you're using try, this try can cause the control flow to immediately exit the function, exit the scope and then the function. So putting here a defer both allows you to do the close at the end if everything goes well, but also to make sure not to forget to do the close if the read fails. And the idea is that this read fails probably because there was not enough memory or the file was too big. So no, but more than one with no block. Okay. This one, you mean? If you mean this, yeah, let me, no, not this one either. Okay, back again. This one. You will still have the same problem though. There's a bunch of tries, and actually this code, this is something that Tornimator pointed out. This is missing a defer in case like the second, like if we fail here, we need a defer that closes stuff, I think. No, not in this version, it's in the block version. But anyway, in any case, the defer here is useful because it allows you to make sure that this happens even if the try is trigger. Oh no, okay, I get your point. Wait, now I connected the dots. You're saying like we could move this above and then close the file immediately rather than deferring, so that you don't keep the file open more than necessary. Yeah, you can probably do some other like optimizations, but like in the practical reality of this Zig DocGen tool is that like it's a fairly short-lived program, so this stuff it's not super fundamental for this case. So yep, let's see. Other comments. Why not Zig args? I don't know. Because while I was programming this, I'll have you know, dear Alex, that while I was programming this, I was on Twitch, and my good friend Matt Knight was with me on Twitch, following along, helping out, and he warmly recommended Clap. Maybe if you were there and you were to lobby in favor of Zig args, maybe I would have given Zig args a chance, but you weren't there, and the early Matt Knight got the worm. In any case, so let's go back to the end. That's it. I really think that the big takeaway for people that want to be good Zig programmers is really to understand that what you are trying to achieve. Why is nice to concatenate expressions? And the answer is, in my opinion, mostly the fact that you are reducing clutter in the lexical scope and maybe also in other ways. But I think lexical scope is the main problem, and really blocks are so simple, so basic, and they do 80 to 90% of the work. And I think that's my conclusion. So let me end the episode. I think it's about time. So let me arm the final screen, and let me bring up the spoiler slide for next showtime. So for next showtime, we should have Frank come back and give us another talk on cryptography, and he has an interesting title for his slide, which is a number, which of course I don't remember, but I'm sure it's going to be interesting. And I think it's about a specific algebra that gives you, the usual cryptography stuff that you want, almost one-way functions. And the second talk that I'm going to give is going to be this one, which I think is going to be it's a bit of a spicier topic for Zig, which is it's a talk on async await, but I'm not going to explain fully async await. I'm not even going to attempt. What I'm going to say, I'm going to try to articulate what makes async await hard to understand in Zig. And the idea is that there are already a good amount of material out there about async await, but there are a lot of people that I've interacted with on Discord and in other venues where they have trouble understanding async await fully. And I was one of them. Like it didn't click immediately for me. I think the moment where I said, okay, now I understand what's going on, it was after I started making changes to the event loop implementation in the standard library. Before then, I had a general idea, but like most other people, I've always been a user of the async and await keywords. And I always knew that the event loop is somehow juggling multiple things at once. But how the whole dance precisely happens, I never knew. I've never known it. And Zig, being a lower level language, kind of forces you to face those facts. Well, it doesn't force you completely, but you are almost forced today, especially because today there are no there isn't a vast library of libraries that do all this stuff for you, and you just import one and you're done, right? We have to create those. So a lot of people wonder, well, how do I implement a web server then? How will then everything end up interacting? And once you start thinking about the details, you realize that async await is not trivial. And I'm going to try to articulate what the blind spots are and what are the things that you have to realize to be able to move forward with your understanding without ending up feeling, feeling like you just can't get it and give up. So let's see. Oh yeah, Frank said in the chat, explain what it is. Oh yeah, it's fast finite field arithmetic and elliptic curves in Zig. Nice. Specifically about all the things in std crypto / I guess it's std.crypto.25519 from an implementation perspective. Nice. Including things that are not in Zig yet. PRs coming soon, hopefully before the talk. Nice. Okay. So I think next showtime is going to be also another interesting one. I hope to see you all there. And I guess that's it. Bye-bye.
This is how we win.